Okay, and our final piece for section 3.8 is dealing with complex fractions, or fractions that contain fractions. And we have a three-part process or a three-part procedure that we can go through to simplify these as well. So the first step in our process is to simplify the numerator into a single fraction. Once we have that done, we do the same thing to the denominator. So we're going to take all of whatever we have in the numerator part, we're going to simplify that down into a single fraction. We're going to take the denominator, we're going to simplify it down into a single fraction, and then we're going to divide the fraction or perform the division and then simplify once again, or reduce if you like. So simplify or reduce. And that's if possible, so it could be the case that we can't. All right, so an example of this is something like if we have 3/4 plus 1/2, and that's in the numerator, so that's all divided by 2 minus 7/8. So this is a complex fraction because we have an overall fraction, a big fraction bar, and then within each of those, within the numerator and within the denominator, we have separate smaller fractions. Okay, so we're going to follow our procedure, and I'm going to skip over little bits of things that we've done enough times already that you're getting bored and don't want to see anymore. So the numerator part, we have a 3/4 fraction and a 1/2 fraction. So I need to combine that into a single fraction. Well, my single common denominator is going to be 4. And that's really because 2 times 2 is 4. So I can get to a common denominator and I can recognize that. So if I wanted to do that, I could say, okay, well, 3/4 is going to stay the same. 1/2, well, to get 1/2 into something over 4, I would multiply the bottom by 2. And since I multiply the bottom by 2, I would multiply the top by 2. And so 1 times 2 is 2. So 2/4 is the same as 1/2. And then I'll write down the rest of this bottom part for us for now, and then we'll look at that. Okay, so I could go ahead and say, all right, well, I can perform this addition as well. I could say, well, for fractions, when we're adding, we add the numerators and bring the common denominator over. So 3 plus 2 is 5, and we're going to leave the 4. So 5/4, and that's still divided by 2 minus 7/8. Now, I need to convert 2 into a fraction that is something over 8. And I could start by saying, well, 2 here is really, well, if I could erase correctly, that would help. 2 is really a fraction. It's 2/1. And if I wanted to maybe go on the next line here and say, well, what is that as an equivalent fraction with 8 in the denominator? Well, if I want to get to 8 in the bottom and I have a 1, I got to multiply by 8. And if I multiply the bottom by 8 and I want to keep the same fraction, I got to multiply the top by 8. 2 times 8 is 16. So my fraction then becomes 16/8, and I'm still subtracting my 7/8. So then to perform that subtraction, same as addition with fractions, if I'm performing subtraction, I keep the denominator and I do the subtraction in the numerator. So 16 minus 7 is 9. So I have 9/8 in the bottom and I have 5/4 in the top. And now I'm at a point where I have completed steps 1 and 2. So really I'm at the point where I'm dividing, and this is where we have to recognize that when I have 5/4 over 9/8, like I do here, that this big bar is really the same thing as division. So 5/4 over 9/8 is 5/4 divided by 9/8. Same thing, different symbol. And now it should become a little bit more clear to me that, okay, well, if I have two fractions and I'm dividing them, that's the same thing as saying take the first fraction, multiply by not 9/8, but its reciprocal, 8/9. And now I could do one of two things. I could go ahead and do this multiplication, but I could look at cross simplifying as well. I could say, well, I know that I'm going to multiply straight across. I'm going to multiply denominator times denominator and numerator times numerator, but I might as well go ahead and see if there are any common factors that I could cancel out. And indeed, there are factors, right? 4 and 8 are multiples of each other. They both have 4 as a factor. So I could cancel out this 4 and say, well, that's 4 times 1, and cancel out this 8 and say, well, that's 4 times 2. So then when I do my multiplication, I get an answer. 5 times 2 is 10, and 1 times 9 is 9. So 10/9 is a simplified version of this beginning complex fraction that we started with.